Myself Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. In this video, we are going to discuss about the problem-solving concepts on storage classes. Now, how many types of storage classes are there and what are the different types of variables we use? Let us discuss on that, and followed by we'll execute a number of programs related to storage classes. Now, there are four types of storage classes in C language. First one is called automatic storage class, register storage class, static storage class, and external storage class. So, based on these storage classes, we say automatic variables, auto variables, static variables, extern variables, and register variables. So, let us discuss today some of the important points regarding these variables. So, let us begin with automatic variables. So, what is automatic variable? If you are declaring the storage class to be of type automatic, then those variables are known as automatic variables or auto variables, and these variables are stored in stack data structure. Now, whenever the number of variables you declared as automatic, then those variables will get the stack space. So, the stack size normally grows and shrinks during the program execution. When a function is called, then that time the stack space is allocated and it stores all the local variable for that function. So this way, whenever it is storing the return address and all the local variables onto stack, we'll say that stack grows. Similarly, when the function exits, then the stack space allocated to that function will be freed up, so that will be available for other users. This process is called stack shrinking. So, stack space grows or shrinks depending upon the function calling and the returning from the function. Local variables, functional parameters are normally automatic type and these are stored into the stack. Any data stored in automatic variables is normally lost when the variable goes out of the scope. That means here we need to understand what is the scope of the variables. So, normally automatic variables are having local scope. That means the scope is within the boundary of opening and closing parenthesis. So, when you are out of that closing parenthesis, then the scope of the variable is lost. So, when the variable will again come into scope, when the function is called again that variable will get its scope. So, the local scope, the automatic variables are bounded by the local scope. Next, let us talk about the static variables. Now, static variables are stored in a separate storage area called the heap area. So, like stack memory, we have also heap memory, and the static variables will get its space from heap area. And the space for static variable is allocated one time only, because normally the global variables are static in nature. So, other variables you can also declare it as static. So, there are two ways you can declare or use the static storage class, one for local variables, one for global variables. So, we have two types of variables. One is called local static variables and global static variables. So, if function variables are declared as static, then they are only initialized once and retain their values during the function calls. So, the static variables in functions are not initialized again and again. They retain their values between the function call. This is one of the important points you need to understand. Next, let us talk about what is extern variable. If the extern keyword is applied to a variable, it indicates that it is declared and allocated space in some other file. So, extern variables are normally global in nature. So, a declaration with the word extern is just like a function prototype. That means it tells the compiler about the existence of the variable, but without actually creating it or allocating any space for it. And these external variables are global in the file in which they are declared. So, without extern, but it may be either local or global in other files. So you have to use very carefully about the extern variables and its declaration as local or global. Next type of variable is called register variables. So the keyword register before the variable name suggests that the compiler that the given variable is stored in CPU registers instead of the memory. So when the variable is declared to be of register type, then the advantage is that it has faster access because CPU registers are having faster access. So instead of regular memory, the variables are stored in CPU registers. Next is the register variables. If you come to the working of register variables, then simply they work as automatic type. So, but the difference between automatic variables and register variable is that automatic variables are stored in memory. That's why automatic variables will have a memory address. But register type variables are stored in CPU registers. So, they cannot have a proper address, and the register variables cannot be referred by a pointer variable or by using the address operator. So otherwise, the scope of the local variables, the scope of the automatic variables and register variables are same. Both are having local scope. So when the scope of the variable is over, then the variable's existence will not be there. The variable will not be alive. So, but only in terms of address, they are different. Automatic variables will have a proper memory address, so you can access those variables using the address operator. Whereas register variables are stored in CPU registers, so it cannot be referenced through pointer variables or your address operator. Now, loop counters are the most common and obvious use of register type of variables. Now, after understanding about these 4 types of storage classes, let us remember some of the important points regarding all the types of storage classes used in C language. Now, before moving on to the important points, first let us understand what do you mean by static local, static global, and extern variables. Now, compiler creates permanent storage for local static variables. Static variables are of 2 types. One is called local static variables and global static variables. So, whenever you declare a variable to be of local static type, then the compiler creates some permanent storage for that variables. But static variables life is fixed to the block in which it is defined. That is, it is local to the block in which it is defined. Whereas, if you declare a static variable to be of global, declaring a global variable as static will make the global static variable available to the file in which declared. That means the difference between local static variable and global static variable is in terms of its scope. Local static variables will have local scope, whereas global static variables will have the global scope, that is within the file or within the program its scope is there. So when the program terminates or when the file closed, then the scope will be over. So this is the difference between local and global static variables. Next comes about the extern variables. Extern variables are available in multiple files of the program. Again, the extern variables in which it is defined it may be either local to the file or it may be global to the other files. So in multi-programming or multiple files development whenever you are doing, then you can use more extern type of variables. Now, let us summarize and understand some of the important points regarding the storage classes. First thing is, if you declare a variable to be of global or extern type of variable, then what is the default value? So the default value for global or extern variable is 0 if it is an integer variable, 0.000 up to 6 decimal places. It is for float type of variables, 0 for characters and null for the strings. So these are the default values, so you need not initialize if you are declaring a variable to be of extern type. Next, if you do not specify the word extern for the global variables, then the compiler will automatically initialize the default value to 0 to a global variable. That means if you are declaring a variable to be of global type without using the keyword extern, then compiler will automatically, if you declare a variable of type global without using the keyword extern, then the compiler will automatically initialize with a default value of 0. Now, when you use the keyword extern for a variable, it is only during declaration, that is, memory allocation will not be allocated at this point. So, to allocate memory, we need to initialize the variable. That means you have declared a variable to be of type extern. That time only declaration. It's like function prototype. Only declaration is done. So, but no memory allocation has taken place. But if you want to allocate memory, then you first need to initialize the variable. Then the memory will be allocated, which is called the definition of the variable. We can initialize the extern variable and it can be initialized globally. So, most of the extern variables are initialized globally. Next important point is an extern variable can be declared multiple times. It is allowed, but initialized only once. Static variables have scope or visibility between the function calls. That means if a function is called again and again, the variables which are declared as static inside the function will retain the value of the previous function call. So therefore, static variables are stored in fixed addresses. This is an important point. And these static variables are initialized at compile time. Therefore, their addresses are known and fixed. That's why because the static variables have fixed addresses and they are initialized during compile time. If you are talking about local variables or automatic type of variables, then the visibility of the variables will be during the code execution. That means whenever the function is called, then whenever the control comes to that function, then the local variables are created and assigned the addresses. That means every time the function is called, then these local variables will be created and assigned address. That means creation, assigning address, initialization for local variables happens during runtime only. So the local variables will not be retained during function calls, or automatic variables will not exist between the function calls. So if you want to retain the values, then you need to go for a static type of variable. Now, to understand this concept, let us move on to our Dev C++ compiler and execute a number of programs to understand the difference between different types of variables used in storage classes. So, the first program is regarding the static variables. Let us write a small program, #include stdio.h. Question is to find the output of the code. Let us first write down the structure of the main program, main function. So int main and return 0. Now, in this, let us write down a loop. Int I is a local variable. Let us write a loop for I is equal to 0, I less than 4, I plus plus. Now, call a function static. Let us write function 1. Okay. Let us call this function. Now, let us write down the definition of this function. This function takes nothing. So, write void function 1 and it takes no parameter. So, also write void. Now, inside this, let us declare a local variable int x is equal to 0 and one static variable static int y is equal to 0. We want to printf the value of x and y. X is equal to %d, y is equal to %d. then print the value of plus plus x and plus plus y. Okay. So let us understand what we have written. We have written in the main function, we have written a loop and we are calling the function for I is equal to 0, 1, 2, 3. So 0, 1, 2, 3. 4 times you are calling the function, right? Now, first time for I is equal to 0, the function is called. So what you are doing inside this function? So we have taken one local variable. So this is local variable or automatic type variable whose initial value is 0, and we have taken one static variable. So static variables retain its value during function calls, but local variables are reinitialized with 0 every time we call the function. That is the difference. So here we want to print the value of plus plus x and plus plus y. So here plus plus x means 1 and plus plus y also 1 for the first time. But when the function is called second time, again x value will be initialized to 0, but y value will not be initialized. It will retain its previous value, which was 1. Now, plus plus x becomes 1, but plus plus y becomes 2. So let us see the output. So first save the program, static.c. Now let us execute. Okay, so let us give /n so that we can see the output properly. So save and run. You can see over here, the value of x is always 1 because every time the function is called, the local variables are reinitialized to 0. Okay, so in this case, x is equal to 0, that is happening every time. So plus plus x is becoming 1, but y value, it is retaining every time. Initially, it was 0, then it becomes 1, 2, 3 and 4. 4 times you are calling the function and y value is 1, 2, 3, 4 and so on. So this is the output of this. To understand the difference between a automatic type or a local variable and a static variable. So let us paste the output. Okay, this is the first program regarding the static and automatic type of variable. Let us go for the next example. Now, hash include stdio.h. Now, int main and return 0. Here we will deal with one extern type of variable, extern int I is equal to 10. Now, we want to print the value of I, so %d, comma I. Now, what will be the output? So, extern1.c. So, if you will save and run the program, what will be the output? You can see over here that there is an error over here. What is that error? I has both extern and an initializer, which is not allowed. If you declare a variable to be of extern, then automatically it is initialized to 0. Okay, so initialization and writing extern, both you cannot do simultaneously. So this part you have to keep in mind. So if I'll simply remove the initialization part and run it again, then it will undefined reference to I. That means the extern, it cannot be declared as a local variable. So let us remove this. Okay, let us remove this and write like this. Extern variables are global variables. So let us write extern int I and then write I is equal to 10. Okay, now you got the value of I as 10 because the extern type variables are declared outside and then you can initialize it. Now let us go for the next example. Find the output of the code. Hash include stdio.h, int main and return 0. Right. Now, let us go for declaring one extern type variable. Extern int I. So its scope is global. Now I am declaring int I is equal to 25. Again, I am writing int I is equal to 9. That means multiple times initialization I am doing for that external variable. Now, again I am writing extern int I and want to print the value of I. Wants to print the value of I. Then, which value of extern it will take? Which value it will take to display the value of I? So, multiple times if you will do initialization, but it will take initialization only once. So, what is the output? Can you see here? Here it is showing the error that redefinition of I. That means you have defined I twice. So, you cannot do like this. So, let me put this line into comment and rerun the program again. So, you can see that it is taking the initialization value of 25. So, multiple times declaration, you don't do it for external variables. So, the output for this program is 25. Okay, now let us move on to the next question. Now, find the output of the code. Hash include stdio.h, int main, and then return 0. Right. Now, let us declare one external variable. So, extern int I and initialize that variable int I is equal to 25, for example. Okay. Now, I am again declaring extern int I. That means again the variable is reinitialized. That means I is initialized more than once. Now, inside the main function, again I am writing extern int I. That means more than once I am declaring the variable. Now, I want to print the value of I. Then, what will be the value of I? So, let us save the program and then check. So, if you do multiple times initialization, then what will happen? So, multiple times declaration is done here and multiple times of initialization is happening here. Now, you can see over here that though multiple times declaration of the same variable is there, but it is taking only once. So, it is storing I is equal to 25 and it is ignoring the initialization or the declaration of the same variable again and again without showing error. So, this way you can try that external variable. You can see that it can be initialized only once. Okay, now let us go for the next question. Find the output of the code. Hash include stdio.h, int main, and return 0. Now, let us declare some global variables in this program. Let us declare int a, b, c is equal to 0. That means global variables by default will have the initialization value 0. But here c is explicitly initialized to 0, but a, b will be automatically will contain 0 values because they are globally declared. Okay. Now, let us write down the main program. Suppose there is an automatic variable int a is equal to 1. And let us call a function. Now, after calling the function, let us increment the variable a is equal to a plus 1 and call the function again. Call the function again. And then finally, print the value of a and b. Now, you can see over here, a is declared to be a local variable also. So, the value of a will will be 1 because local variables will have more priority than global variables. So here B is not declared as a local variable. So B is the global variable we are using over here. Now let us write down what is there inside function. So the function returns nothing. So void function1, and it takes no argument. So void. Now declare a variable to be of register type, register int a is equal to 2. So the register type variables will not have memory address, but you can use it and it is faster in accessing. And take another local variable, int b is equal to 1. Now a plus is equal to plus plus b. That means which is same as writing a is equal to a plus b. Okay. Now print the value of ab. Printf %d, comma a, comma b. What will be the output of this program? Now you can see here, this program contains two types of variable. One is called automatic type and another one is called static type, register type variables. Now let us save this program as auto1.c. Okay. So let us understand what is going on. Initially, a is equal to 1. Let us look at the main function first, and then you are calling the function. So when you call the function, you are not passing anything. So no arguments you are passing. So how the function executes? It is initializing a local variable which is of register type, int a is equal to 2. Now b is equal to 1. So b is also a local variable over here. So a and b both are local variables. Now a is equal to a plus b. So what is the value of a? Is 2 plus b. Plus b is how much? It is also 2. So a plus, that is 2 plus 2, it becomes 4. So print the value of ab. So a becomes 4 and b becomes your 2. So 4 and 2 will be printed. 4 and 2 will be printed. Now once the function is over, again the control comes back to the main function. Then here a is incremented by 1. So a becomes 2 now. Again you are calling the function but not passing anything. Again it goes to the function and again re-initializing the local variable int a is equal to 2, b is equal to 1. Again it displays 4 and 2. Okay. Then it comes back to the main function. So where it prints the value of a and b. So a and b, a has become 2 and b the global variable. So it will print here 2 and 0. Let us understand and execute and see the output. Let us put some /n so that you can see the output properly. Right. Now execute the program. You can see over here 2 times function has been called and it has returned 4, 2 and 4, 2 for AB values. And in the main function to print the value of A and B, it is 2 and 0. So this is the correct output. So let us copy paste the output in the program. Okay. After this, let us move on to another program. Find the output of the code. Hash include stdio.h, int main and return 0. Okay. After writing the structure of the main program, let us understand one more program. Let us take two local variables int I and j and write down a loop for I is equal to 0, I less than is equal to 4 and I plus plus. Inside this, we are calling a function j is equal to, increment is the name of the function, and by passing the value of I, we are calling this function. Okay. Now, let us write down what is increment function. Increment function returns an integer. The name of the function is increment and it takes one argument which is also integer. So what is the function type? With argument and with return type. Now inside this we have a static variable, static int count is equal to 0. Count is equal to 0. Now static variables normally retain their values during function calls. Now here we are doing count is equal to count plus I, and we are returning the count over here. We are returning the count variable. Now what will be the output of this program? Now let us understand how the program executes. We have two local variables I and j. So I is the looping variable. First time I is equal to 0 and we are calling increment function by passing 0 to that. Okay. Now come to increment function. Integer I is equal to 0 here, and let us take a count variable which is initialized to 0. Now count becomes 1. Count plus I. So count is 0 plus I value is also 0. So it is count is now 0. And return the count, so it will return 0 first time. Again. Now in the main function, again I is incremented to I plus plus, so I becomes 1, and increment function is called again with I value 1. So it will go back to the increment function. Now I is equal to 1. Now count variable will not be reinitialized to 0. It will retain its previous value. Its previous value was 0. Now I value is 1. So it becomes 0 plus 1. It is 1. Okay. Next time I value will be 2 and count value is 1. So it will be 1 plus 2, 3. Next time I value is 3. Count value will return as 3. So it becomes 6. And the last time it will be I value will be 4 and count value is 6. So 6 plus 4 it will be 10. So hope the answer should come as 10. Let us check it. Yes. So here we are not displaying the value of j. Let us display the return value. So let us write down this statement inside the loop and display the value of j every time. %d / n, the value of j. Let us display it. Now let us see every time the function is called, what is the return value of j. So you can see here the function is called 5 times. So first time j value is 0, then 1, then 3, then 6 and 10. So this is the correct output. So let us paste the output over here. Okay. So this way, a static variable retains its value during function calls. You have to understand in this example. Now let us move on to the next question. Find the output of the code. Okay. First, let us write down the structure of the main program. Hash include stdio.h, then int main and return 0. Now let us understand another program related to static variables. So declare a static variable, static int I is equal to 5. Now if -i, then let us call the main function here. Okay. So this is recursion and printf %d, I value. Okay. Now let us save this program. Now try to understand what will be the output of this code. Now integer I is equal to 5. -i, that means I 4. So if condition is true, you are calling the function again. So, and you are displaying the value of I. So whenever it is a static variable, when the function is called again, then it will retain the previous value of I in every iteration or every function call. So the output of this code is every time, you can see over here, the value of I is 0. Okay. Now let us go for the next question. Now find the output of the code. Start with hash include stdio.h int main and return 0. Now in this, let us call a function thrice from the main function. We are calling a function thrice. Okay. And let us write down what is the function definition. This function takes nothing. So void name of the function and it takes no arguments. So let us write down the function definition. Now inside the function there is a automatic type variable. So auto int I is equal to 5 and one static type variable static int j is equal to 5. Okay. Now one register type variable register int k is equal to 5. So we have used over here 3 different types of variables. One is automatic storage class, one is static storage class type, another one is register storage class type, and do I++, j++ and k++. After that, print the value of I, j and k. I, j, k. Now, in this program, you need to understand the variable types. The local variables are the automatic type and registered type variables are treated to be local variables, and every time the function is called, those variables are reinitialized again. But static variables only retain its value during function calls. So first time when the function is called, then what will happen? I is equal to 5, j is equal to 5, k is equal to 5, and I, j, k values are incremented. And if you are displaying the values of I, j, k, you are getting that it is 6, 6 and 6. Okay. All values are incremented by 1. Now, second time when you are calling the function again, then I and k, one is automatic type, one is register type, will be reinitialized to 5 again. But j will retain its value. So, what was the earlier value of j? J was 6. Now in this function call, j becomes 7. Next time, third time when the function is called, again I and k are reinitialized to 5, whereas j will retain its value. Now j++ becomes, make it 8. So this way you need to understand the difference between different types of variables used in your program. So automatic and register type of variables will have a local scope, whereas the static variables will have also local scope in this program, but it will just retain the values between the function calls. So next question, let us move on to the next question. Find the output of the code. Hash include stdio.h int main and return 0. Now, let us declare different types of variables. Suppose automatic int I is equal to 5. Static int j is equal to also 5 and register int k is equal to 5. And let us declare one more type of variable, extern int L is equal to 5. Now, print the values of I, j, k and L. So, %d, write 4 times /n, print the value of I, j, k, L. Okay. Now, let us write this inside a function. This is called your function this takes no argument. So void function and it returns nothing. And let us write down our main program and call this function. Call this function twice. Then what will be the output of the code? Right. So here all the 4 types of variables you have used over here. So you know that the automatic and register variables are having local scope, whereas static variable will retain its value during function calls, and extern is for having its scope that is global. Now let us execute and see. Now, what is the mistake that you have committed over here? When you declare a variable to be of static type, then declaration adds using the keyword static and initialization at a time, you should not do it. It will give you error. So what we will do, we can remove the value which you have initialized for L. Now we can test the program again. Now undefined reference to L, that means the external variables should be declared outside. So let us remove this and keep it outside because it is having global scope. Global scope. Okay. Now let us rerun it and check. Now here again write down extern int L. Okay. Now here the mistake is the function returns nothing. So let us remove this part and rerun it again. So here let us initialize this variable with some value. Int L is equal to 5. Now let us check what is the output of the code. So you can see over here the function is called twice. So it is 5, 5, 5, 5. And in both the cases, it is showing the same output because the function is called twice. If you do some changes to this variable, then you can observe. Suppose for example here, if I'll do J++ only to understand the difference between static and other variables, then if I run, then you can see that the value is retained in the function calls. So first time J++ becomes 6, second time it becomes 7, but your automatic and register variables are local. So they are every time when the function is called, they are reinitialized to 5, and external variable is having global scope throughout the program. The value of L will be 5. That's why you are getting the L value as 5. Okay. So this way, by doing a number of programs, you can understand the difference between different types of variables used in C program. In this video, we have understood different types of storage classes and different types of variables used in our C program. We have also discussed about the automatic type, auto variable, register variable, static variable, and external variables. Thank you so much.